Hey, in the last video we learned about our different types of angles when we had two lines cut by a transversal. What we're going to do now is look at what happens when these two lines are parallel lines, okay? Cut by a transversal. Well, we talked about corresponding angles, and last time we said that if we had that our corresponding angles are in the same position, such as 1 and 5, 2 and 6, 4 and 8, 3 and 7. Now, whenever you have parallel lines, all of these corresponding angles end up being congruent to each other. So angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. Next up, we're going to look at our alternate interior angles. And again, alternate interior angles all dealt with our transversal here. And they were on alternate sides, and they were on the interior of our two parallel lines. So angle 4 and angle 6 are alternate interiors, and angle 3 and angle 5. Well, anytime we have these parallel lines, which is our symbol for parallel lines right here, anytime we have that, we know that our alternate interior angles are going to be congruent. So angle 4 is congruent to angle 6, and angle 3 is congruent to angle 5. Alternate exterior angles. If we go back to those, again, here's our transversal, and they are going to alternate sides, and they're going to be in the exterior. Well, according to our alternate exterior angles theorem, our alternate exterior angles are going to be congruent. So angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. And then we have same side interior angles. These are the ones that are different. So here's our transversal. And if they're on the same side and interior, so angle 5 and angle 6 are on, they're both interiors, but they're not on the same side of the transversal. They are linear pairs. Haha, I wondered if anybody would remember. They're linear pairs. So if I go this way, since I know 4 and 6 have to have the same measure, does it make sense that if 5 and 6 make 180 and 4 and 6 are the same, that 4 and 5 also have to be 180? Yeah, so also 3 and 6 have to be 180. So I always remember this one as being the one that's different with same side and supplementary. That all of those S's go together. So you've got same side, those are supplementary. Well, let's see which angles we know, and can we figure out why we know them? So which angles measure 55 if this is the only one we're given? So let's look at some angle pairs that we do know. Let's talk about how we can go from 55 degrees to our angle 2. What kind of angles are those? Well, these are back from chapter 1. These two angles are vertical angles. So I know that the measure of angle 2 is also 55 degrees. And how do I know? Well, they're vertical. So vertical angles. Alright, now let's see what else do we have. How can I go from angle 2 to angle 6? Alright, 55 can go to angle 2, and then angle 2 can go to angle 6. So in turn, I know that the measure of angle 6 is also 55 degrees. And what type of angle pair is angle 2 and angle 6? Well, those are corresponding angles. And those are also going to be congruent. Then last but not least, how can I go from 55 to angle 7? Well, I can either use angle 2 to get there, because 2 and 7 are alternate exteriors, or I could use 6 to get to 7 because those are vertical. So we also know that the measure of angle 7 will be 55 degrees, and I can say that it's vertical to 6, it's an alternate exterior with angle 2, or that it is corresponding with 55. So you have many different options on how we know angle 7. So let's look at this next question. What are the measures of angle 3 and angle 4, and which theorem or postulate justifies each answer? Well, here we know that this angle is 105 degrees. And now I need to somehow or another get to angle 3. So I need to know what's my connection between 105 degrees and angle 3. Well, those are alternate interior angles. And I know that alternate interior angles are congruent, which tells me that the measure of angle 3 is also going to be 105 degrees. Now, what about angle 4? So I have angle 105 here and angle 4 here. Now, these two are on the same side of my transversal Q, and they are both interiors. Well, same side interiors are supplementary, which means I need to do 180 minus 105, which gives me that the measure of angle 4 is 75 degrees. So our theorem that we used to find angle 3 was our alternate interior, and our theorem that we found angle 4 was our same side interior. Now, our next question. Find the measure of angle 1 and justify your answers. Well, we already went through and we found that this one was 105 and that this one was 75. Now we're looking for angle 1. Well, which one does angle 1, is it going to be easier to find with 105 or is it going to be easier to find with 75? Well, this pair to 105, we don't have a name for that. You see how they're on the same side and they're both exterior? Well, that's not really a pair we can work with. What if we look at this transversal L? And then I can see here that these are alternate interior angles, which lets me know that the measure of angle 1 is also going to be 75 degrees, since our alternate interior angles are congruent. Now, we're going to be looking for the value of y. Well, let's look at where we have our parallel lines. And those are right here and right here. And I know those are parallel by those arrows that are on them. So I want to look at the stuff right now that's on the interior of our angles, or in the interior of our parallel lines. So if I look here, you can kind of see it somewhat shaded, that if I just take this line out, that's going to give me one angle. And using my angle addition postulate, I can say that that one angle will be y plus 40. So using all of that together, I can use my two parallel lines and this transversal. I do not need the transversal here in black. This line does not help me because I'm going to replace this with y plus 40. So now I know that these angles are on the same side and they are interior, which means that they are supplementary. So I need to do y plus 40 plus 80 equals 180 degrees. So if I simplify this, combine my like terms, 40 and 80 makes 120, and subtract 120 from both sides, I get that y equals 60. So angle y is 60 degrees. Next up, I've got this lovely trapezoid here. And do you guys see the parallel lines right here and right here? Those lines would continue on. So you kind of have to think about like this line would be your transversal. So if I have that, I know that this angle and this angle are on my same side and they are interiors between my two parallel lines, which lets me know that these two angles are supplementary. So I can do 2x plus x minus 12 equals 180. So to simplify this, I have 3x minus 12 equals 180. So now I'm going to add 12, and I've got 3x equals 192. So then I'm going to divide by 3, and x equals, well, 3 goes into 19 6 times, which is 18. So I have a remainder of 1. So how many times is 3 going to 12? 4 times. So x is 64. Now I'm going to take that same approach with y. I'm going to use that one as my transversal, which means that 3y and y plus 20 are same side interiors. So I can do 3y plus y plus 20 also equals 180. So that's 4y plus 20 equals 180. Now I'm going to subtract 20 from both sides. That gives me 4y equals 160. Divide both sides by 4. And y is, well, 4 goes into 16 4 times and then with a 0. So we have a 40. Next up, we're going to look at what's called a proof. And a proof means we're going to be given a statement and we need to prove something about this with our picture, okay? And using stuff we've already learned. Well, we're given that A is parallel to B. So A is parallel to B, which means we can use any of our angle pairs that we've learned about. And our goal is to prove that angle 1 is supplementary to angle 8. So what we know is we know we have parallel lines and we can use our angle pairs that we have. The angle pairs we have are 1 and 5 are corresponding, and we have that 5 and 8 form a linear pair. Well, what we need is for angle 1 and angle 8 to be supplementary. So somehow or another we need to get the measure of angle 1 plus the measure of angle 8 to equal 180. So here's our plan. We're going to show that angle 1 is congruent to angle 5 and that the measure of angle 5 plus the measure of angle 8 equals 180 degrees. So we're going to substitute the measure of angle 1 in for angle 5 so that we can get angle 1 and angle 8 to be supplementary. So let's see how we can do that. When you write a proof, you set it up with 2 columns. The left column is called statements and the right column is called reasons. Well, the statements are just things you're telling me that you know are true, and your reasons is the list of all the geometry that you know they're true. So A is parallel to B. Well, we know that because that was given to us. So from there, I know that angle 1 is going to be congruent to angle 5. And my reason is that if our lines are parallel, then our corresponding angles are congruent. Well, from there, I know that the measure of angle 1 is going to equal the measure of angle 3. Measure of angle 1 will equal the measure of angle 5. And that's just congruent angles have the same measure. That's what it means to be congruent. Well, I also know that angle 5 and angle 8 are supplementary right here, and that's because they form a linear pair, and linear pairs are supplementary. And so by our definition of supplementary, I know that the measure of angle 5 plus the measure of angle 8 equals 180. Well, what I'm going to do is I'm going to go back up here and I'm going to look and go, well, right there I said 1 and 5 are equal. So what I can do is I can take out 5 and I can substitute in angle 1. So there's my substitution property that says if they're equal, I can switch them in and out. So now I know that angle 7, by step 7, I know that angle 1 and angle 8 are supplementary because my definition of supplementary angles says that they add to 180. And we'll do more of these in class, so don't let this stress you out too much. Bye, y'all.